Hello everyone, this is Mr. Avila helping my Algebra 2 students get ready for the Unit 1 exam. Here's the next question on sequences. The first two numbers, this is question number 6 by the way. The first two numbers in the sequence are f of 1 equals 3 and f of 2 equals 9. So we get the first two terms of the sequence. Now we have question A, which by the way on your practice test is on the next page. We accidentally split that. So question A, you're answering here. If f is an arithmetic sequence, what would be the nth term? By the way, when I say nth term, I mean explicit sequence. So we have a first term that is 3, and the second term is 9, and I tell you this sequence is arithmetic, what would be the next three terms? Arithmetic means we're adding or subtracting the same number over and over again. So in this case, if I were to see how much we're adding by, 3 plus 6 gives me 9, we're going to repeat that. So we're going to write 3 plus 6 is 9, 9 plus 6 is 15, then 21, then 27. So we created our arithmetic sequence with the starting terms 3 and 9 that were here. First term 3, second term 9. We're being asked to write an explicit sequence for this arithmetic situation. So we have to look up our formula for an arithmetic sequence explicitly. In that case, the explicit form is f of n is equal to first term plus growth rate times n minus 1. So in this case, I'm going to write f of n is equal to first term, which is 3, plus growth rate, we're adding 6 every time, times n minus 1. Okay, that's the function that if I plug in a 1, 2, 3, 4, 5 into that function, we will end up with our sequence, our arithmetic sequence that we have here. B now, same two starting terms, 3 and 9. So we're starting with 3 and 9. But in this case, we now have a geometric sequence that you're going to make. So if it's geometric, we're multiplying by the same number over and over again. So 3 times what would give me 9? That would be the number 3. So since it's geometric, we're going to multiply by 3 over and over again. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81, and 81 times 3 is 243. Multiplying by 3 over and over again. Then, if we want to create our explicit function for this geometric sequence, we are going to look at our notes and find that formula. And that formula is f of n is equal to first term times the growth factor to the power of n minus 1. So here in this case, our first term is 3, so I'm going to write f of n is equal to 3 times, so first term is 3, and the growth factor is 3, so I'm going to write 3 to the power of n minus 1. Both of these explicit sequences work when n is greater than or equal to 1. They work from the first term all the way up forever, and that's what we have. So we created an arithmetic sequence that started with 3 and 9, a geometric sequence that started with 3 and 9, and we wrote the explicit formulas for each one. Good job, everybody. Let me know if you have any questions. I'll see you in question number 7. Almost done.